So one of these sort of issues I've been struggling with for navigating patterns is the idea of forbidden knowledge. And it's just a tough thing to sort of convey to people who don't see it, right? Which is really what not so much this channel, but navigating patterns is all about. I use this various ways. Uh, I want to talk about forbidden knowledge in the computer space. So, sort of the history, if you read the history, if you understand the history, or if you were there for a significant portion of it, of language development on computers, notice it's language development, computer programming languages, is that we went from a mix of relatively simple and relatively difficult languages to do sort of different things, right? To a flattened, sort of more generic, all programming languages are variables and recursion now. Um, and then we've made up sort of designators like how you're thinking about it. Is it functional or procedural, object oriented, etc. Of course, everything's a mix. Knowing why we have things like object oriented programming, where that impetus came from, what the telos, the final cause, was in developing it. It turns out to just explain a lot and help you to use it better. If that's, or figure out, should I be using object-oriented programming? And you have the rise of languages like Java, which are really all-purpose, sort of, they can be used different ways, right? It can be an OO language, right? That's true, but you don't have to. I mean, you can use it as an aspect-oriented programming language too. Like, those two things couldn't be further apart in some sense. You can use it as an event-driven language as well, and there's all kinds of crossover. These categorizations and distinctions, some of them are very good and some of them are awful. They're just terrible. And the reason why is forbidden knowledge. So if you look at the history, what you're going to find is we got C. C is a fantastic language. I love C. It's a mess. It's a mess. Why is it a mess? Because it puts a burden on the engineer, on the software engineer, to manage memory. Now, I would argue if you don't know how to manage memory, you shouldn't be programming in any language at all, because no programming language can prevent you from mismanaging your memory. This is easily proven time and time again. I've gone to many companies with automatic garbage collected languages like Java. Java is a big example, but also other languages. And they have memory leaks all over the freaking place. And they have memory leaks because garbage collection can't get around your stupid programming tactics. It can't. All it can do is free local memory that it knows in the local scope is no longer being used. There are tricks you can use to kind of figure out the global scope stuff, which would work, except it changed how programming languages work. C is compiled. They moved away from one-time compilation and towards real-time compilation, or byte compiled code or interpreted code. Right. And there are some distinctions there and they're worth having. I'm not going to get into those. There's no point. If you don't know them, you don't know them. It's fine. It's forbidden knowledge. It's fine. In the quest to make things easier, they made a bunch of changes, and those changes are not compatible with one another. You can do garbage collection in a compiled language really easily and very well. I'm not saying you should. I disagree with the idea of garbage collection wholesale, because you could do something better, entirely better, which is you could run a simulated garbage collection on your code, or maybe as part of the compilation, one of the compilation stages, because you should have multiple compilation stages, because actually more pipeline is better. I can get into that in a minute. And it can tell you where you've made memory mistakes so that the computer makes you a better programmer. Wouldn't that be better? But we're not doing that. We're letting the computer do the work, which makes us weaker programmers. Why do we have things like garbage collection? Well, the reason why we have these things, for the most part, not entirely, Java is probably an exception to this, although I don't remember the whole history of Java. Garbage collection is really handy and creates a bunch of boilerplate code that you no longer need to deal with for certain circumstances. You know where it's not good? For your whole software project. If you know that, because you spent 10 years learning that by programming the hard way, it's a very useful tool. When you give that tool to a new programmer, they're going to misuse it and create memory leaks, big ones. On garbage collected languages, when you create a memory leak, it's not one of these like, oh, you're leaking 8 bits every, million instructions. It's you're leaking 10 gigs. You don't know how. That's usually what happens. And I'm not being hyperbolic. I'm giving you real world example that happened multiple times to me where I was like, you guys get a memory leak. And they're like, can you know that? Because you just allocated 10 gigs of memory and you don't have 10 gigs of data. It's really not a difficult equation. Now you could say, look, I've got a gig of data and I need 1.5 gig for processing it, or maybe even 2 gig for processing it. But by and large, with some corner cases that are easy to spot, you never need that much data. You just never need it. And so that's good to know. So when you build these tools for these people that do not have this experience, you end up in a bad place. And that bad place is called handing out forbidden knowledge. And they misuse that knowledge. That's what they do. They have no choice. They don't have the right context via experience and time, because experience takes time, but we discount that connection. The more time, the more experience. That may not translate into you being better, but on average it will for most people. So it doesn't apply to the individual very well, but it does apply to the group very well. A lot of things are like that. There's an asymmetry in how you calculate things at scale. I talked about scale before, and navigating patterns. I don't know if I've talked about it here. So that's super important to know. And that's pretty much the point of this video, was to sort of start talking about forbidden knowledge so that I can get used to talking about forbidden knowledge so I can do a better video on this, not about computers, hopefully, on navigating patterns.